Hello, this is video 3.4, Systems of Equations in 3 Variables. Now, we've already done systems of equations with 2 variables. So in this section, we're going to solve systems of linear equations, which are just straight lines, in 3 variables, and we're going to solve real-world problems using systems of equations in 3 variables. So we only have one vocabulary word. It's called ordered pair. It's a solution to a system in 3 variables that's written in the form of x comma y comma z. All right, so let's get right into it. So let's look at our video notes. And let's look at the types of solutions we have. Because there are 3 variables, we actually have a plane, right? So we're going to have one solution, infinite solutions, or no solution. So here are the categories. When you have one solution, that means, so you see the blue, the orange, and the green represent 3 different planes, and they're going to intersect at one point, x, y, z. Infinite solutions, meaning 2 situations can occur. They can all be the same plane, just like we have the same line in systems of equations, so then it's infinite solutions. Or do you see they all intersect at this line, this vertical line right here? And we know vertical lines have infinite solutions, therefore they have infinite solutions because they cross all on that line. Then you have no solutions, and here are the possibilities. They're all 3 different planes that are parallel to each other, so that means the planes never cross. Remember, a plane goes on forever in all directions, but we can look at a plane and represent it by a rectangle shape or, a square piece of paper. But ideally, or technically, this plane goes on forever in every section. So they're parallel, so they have no solutions. Here, 2 of them are parallel, and 1 of them intersects both of them, but they don't all 3 intersect at any point or points. So this has no solution. And here, same thing here. We don't have parallels, but the orange and the blue plane cross at this line. The orange and the green cross here. And over here, the green and the blue cross, but they don't all 3 cross at the same place, so there is no solution. How do we solve these? Well, we use our system of equations just like we did, except for now we have to be careful, we have to be organized, and we have to identify them. So I would suggest when you start off writing them, I don't know why it keeps going here, you identify these as, give them names, A, B, C, just like you did with 2. 2 is not that big of a deal, but 3, it gets really challenging. So we're going to start with the first 2 solutions. So we need to decide, we look at all the variables and go, which ones are going to be easier to simplify or to get rid of, because we're obviously going to use the elimination process here. Well, it looks like we want to get rid of y's. So if we start with the equation a and b, this is coefficient is -2 and this is +2. So for them to eliminate, meaning being opposite to equal 0, we need this coefficient to be +2. So we're going to multiply equation b by 2. So let's rewrite it to say we're not doing anything to equation a. So we're going to write it just as is. And then we're going to multiply the second by 2. So -8x plus 2y minus 10z equals -72. Now we simply add the equations. This cancels out. This becomes -5x minus 6z equal -37. I'm going to call this solution D. All right. Then I'm going to take the next 2 equations and I'm going to multiply b again by 3. So I'm going to do equations b and c. So let's use a different color. So we're going to get -12x plus 3y minus 15z equals -108. And then we're not doing anything to equation c, so we just rewrite it. Don't try and do all these steps all up here in your head. Rewrite them. The 3 equations, you're going to make a lot of mistakes anyway. So this becomes negative 7x minus 12z equal negative 77. And I'm going to call this equation E. So now I've got two equations, D and E. Now I'm going to use those. Let's change it to orange. So negative 5x. So let's look at that. It's going to be easier to get rid of the z's. Here I would have to multiply D by negative 7 and E by 5. Here I just need to multiply equation D by negative 2. So let's go ahead and change that now. So it's going to be positive 10x. So we're multiplying this by negative 2. So let's write that in, it helps us. Plus 12z equal 74. Then we're just going to rewrite equation E, negative 7x minus 12z equal negative 77. They're going to cancel out. We end up with 3x equal negative 3 and x equal negative 1. So we've got our first point. Now, I can't put it into one of the originals because then I'm left with two variables. Can't solve. So I put it in D or E. It doesn't matter. So if I put it in D, I get negative 5 times negative 1 minus 6 times z, equals negative 37. And then I just simply solve for z. I'm not going to do the work. You can look in the book if you're interested, or you can ask me in class if you don't know how this is basic algebra, solving an equation for z. I get z equals 7. So now I have two variables. So now I can choose any of the three equations and put it in. So I'm going to put it in, does it matter? No. 3 times negative 1 minus 2y plus 4 times 7 equal 35. And I'm going to get negative 3 minus 2y plus 28 equals 35. Negative 2y plus 25 equals 35. Negative 2y equals 10. Y equals negative 5. Okay, but now, so my answer it's 3 coordinates. So I got to make sure that I put it x, y, and z. It needs to be written like this in this order. If you switch the orders up, remember this is going to be representative of x, y, and z. It will be wrong. Now you need to make sure, since we used the first equation, we need to check to make sure it works for the other two equations, because we could have done bad math or we could have had an issue, so we need to make sure that it worked for all three. Pause this, do guided practice 1A and 1B. All right, so now let's look at example 2 on our worksheet. Oops, on our video notes. All right, so example 2 says solve each system. Now we can have a possibility of no solutions or infinite solutions. We already saw the situations and the cases. So planes are a little bit harder to see, so we have to do them algebraically. So we take these equations. So our equations are 5x plus 4y minus 5z equal negative 10, negative 4x minus 10y minus 8z equals negative 16, 6x plus 15y plus 12z equals 24. So here are our equations A, B, and C, and we want to stay organized. So first thing I'm going to do, I'm like, what do I want to try to get rid of? Well, my smallest numbers are going to be 5, negative 4x. So let's just roll with this one. So the least common multiple between these two numbers is 20. So I have to multiply this by 4 and this by 5. And then if I want to get rid of these, I'm going to multiply this by 3 and this by 2. Now, so let's try it. So let's do, let's do the second two. Multiply this by 3 and this by 2. Our least common multiple is going to be 12. So we get negative 12. And they're already opposite, so they can both be multiplied by a positive number. Remember, you have to multiply every term in the equation. or you will get it wrong. And you'll get some crazy numbers and you'll be going, what did I do wrong? Okay, so these are our new equations. We use equation B and C, and we multiply B by 3 and C by 2. Now let's add them. So we get 0 equals 0. It's a true statement. So that means they're the same plane, so they have infinite solutions. So we need to make sure that it intersects with one of the equations. So I can take B or C and do and start the system process with equation A. So we're going to use A and B. We're going to multiply A by 4 and B by 5, which gives us negative 20x plus 16y minus 20z equals negative 40. Then we're going to have minus 20x minus 50y minus 40z equals negative 80. When you add these together, you're going to get negative 34y minus 60z equals negative 120. Because it didn't cancel out to give me a false statement, or if it gave me a true statement, then I would say they're all three the same plane, so it's infinite solutions. These two are the same plane, so they cross this one. The only other situation for it to cross, if you had a plane, okay, so they're going to cross at least at some line. They're not going to cross just at one point, because you only have technically two planes because two of them are the same. So we're going to get infinite solutions here because we know it crosses. Oops, I did something wrong. Okay, so we get true solution. Then when we intersect it with the other one, that's going to be B. Okay, so then this is infinite solutions. Okay, so now let's do B. So this one's right. Sorry, I was just getting my notes mixed up here. So let's look at example B here. So it's going to be, oopsie, negative 6a plus 9b minus 12c equals 21, negative 2a plus 3b minus 4c equals 7, and then you have 10a minus 15b plus 20c equals negative 30. Okay, since I've got the letters A, B, and C, I probably don't want to use that to name them. So I'm going to name them 1, 2, 3. Name them whatever you would like to name them. So again, I'm going to take the first two equations, and I'm going to attempt to get rid of the A's. So they're both negatives, and the least common multiple is 6. This is already 6, so I'm going to multiply this by negative 3. So I've got negative 6a plus 9b minus 12c equals 21. Then I'm going to have 6a minus 9b plus 12c equal negative 21. When I do this, I get 0 equals 0. That's a true statement. So they're telling me, so since I used equation 1 and 2, that these two are the same planes, so they have infinite solutions. So I need to see if they intersect with the other, with equation 3. So I'm going to use, I'm going to multiply equation 2 by 5, and I'm going to get negative 10a plus 15b minus 20c equals 35, and I get 10a minus 15b plus 20c equal negative 30. Well, when I add these together, I get 0 equals 5. I get a false statement that tells me they do not cross. I can go back and check my math, make sure I use the right numbers, the right equations, that I didn't mix two equations up together. And then if I multiplied one of them by a number, that you distribute it through. So this tells me these two planes do not cross with this one, so you have no solution here. All right, go ahead and pause it and do guided practice 2A and 2B. Now we're going to come back and we're going to do the real world problem. Okay, this real world problem, it says refer to example 3 of the lesson. Write and solve a system of equations to determine how many seats are in each seat of an amphitheater. So they tell us here, seats, we have an amphitheater. You got 3 different sections, A, B, and the lawn. The amphitheater says this, seats closest to the stage are $30. So that would be section A. The next section is $25 and the lawn section are $20 each. They tell you there are twice as many seats in section B as in section A, and when all 19,200 seats are sold, the amphitheater makes $456,000. So we have to write a system of equations and we have to solve and we have to find out how many seats are in each one based on the given information. So the first thing we have to do is we have to identify what our variables are. So X is going to be the number of seats in section A. We're going to let Y equals section B. And we're going to let Z equal section C. Now they tell us section A, they imply it, are $30 a seat. These are $25 a seat. And the lawns are, oh, this is going to be lawn, sorry, not section C. And the lawns are going to be $20 a piece. Now we know that X, the number of X plus the number of Y plus the number of Z is a total number of seats. And they tell us that there is 19,200 seats. They don't tell us directly, they imply it by saying when all 19,200 seats are sold, they make they bring in this much revenue. So how do we find that? So it's going to be, if each one is 30, it's going to be 30 times X plus 25 times Y plus 20 times Z, and our revenue is going to be $456,000. Now we need one more, obviously, and they give it to us, and it says there are twice as many seats in section B as in section A. So B is Y, so our equation is going to be Y equals 2 times the number of seats in X, because there's twice as many in Y. So now we have our system. So there's 2 ways of doing this. We can start with these 2 and then plug Y in, or we can directly substitute 2X into both of these Y's here. So let's do that. So we get X plus 2X plus Z equals 19,200. 30X plus 25 times 2X plus Z, 20Z, equals 456,000. So when we simplify these, okay, so here, keep your braces because it helps you to keep organized. We have 3X plus Z equals 19,200. Then we have 25 times 2 is 50. X plus 30X, we have 80X plus 20Z equals 456,000. So now we have 2 variables. We can choose, I think the easiest one to get rid of is the Z's. So we're going to multiply that by a negative 20, which gives us negative 60X minus 20Z equals negative 384,000. We're not multiplying the other one by anything, so we just rewrite it. Then we add, we get 20X equals 72,000. We solve for X, and X is 3,600. So X is the section A. So now let's put it into this equation, right? So Y equals 2 times 3,600. So the number of Y seats is 7,200. Now we need to find Z. So we're going to put it in this equation. It's the easiest. So we're going to say 3,600 plus 7,200 plus Z is going to equal to 19,200. When you do the algebra, you get Z equals 8,400. All right, so now we're going to take these values and we are going to put them in here to check them. I know they're correct, so we're not going to do that now. But then your answer is going to be 3,600 tickets for section A, 7,200 tickets for section B, and 8,400 tickets for the lawn. So stop the video, attempt guided practice 3. It's a real world situation. You have to write your systems, your equations, identify your variables, and then solve. All right, we'll see you in class.